Moving on to the got it problem. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend together on toppings. How many of each type can you get? When I scroll through this problem, I see that I have a maximum of $10. So what I'm going to do is I'm going to make a maximum of $10. So I'm going to make an equation that is less than or equal to 10 because I only can use 10. So whatever is on this side has to be smaller than or equal to 10. So let's find some other values that deal with money, okay? Because this is going to be my money equation. I see that I have $1 for every vegetable and $2 for every meat topping. I have my first inequality that I can graph. We need to figure out which one we want to be the x and y axis. We'll talk about that in a minute. Now another thing that it says is that you want at least 5 toppings. This is another total. Now if I want at least 5 toppings, that means that it needs to be greater than or equal to 5, because at least means you want that or more. So I say the veggies plus the meat. So I have my 2 equations. Notice this graph, you might want to write this down. This graph only includes the first quadrant because you can't order negative vegetables and you can't order negative meats. So we'll go ahead and solve each of these for a variable. I'm going to solve them each for v, since v is by themselves. That's going to make this axis the v axis and this axis the m axis. You won't get it wrong either way, but I like to solve if v is by itself in both problems. That's how I like to solve. So in this equation, I'll take 2m to the other side. So that's v is less than or equal to negative 2m plus 10. We now know how to graph that because it looks like y equals mx plus b. This equation will solve for v again. V is greater than or equal to, in this equation, take the m over, negative m plus 5. So I have my 2 equations. I'm going to graph them over here. Now one thing to note in this problem, the reason it's an inequality, let's write this down, it's an inequality because there are a range of answers. Okay? In other words, it's not saying that you want to be super exact, it's just giving you some limits, and then you have to find the range of the answers. So let's graph the first one. Let's go up 10, and then down 2 over 1, down 2 over 1, down 2 over 1. I'm going to do that until I meet both sets of axes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here at the very top. How convenient. Down 2 over 1. When you connect these, think to yourself, should I be using a solid or a broken line? Hopefully you will decide that you need to use a solid line. So we connect using a solid line because it's equal to. And I'm only going to take it from one axis to the other to indicate, that I can't have negative amounts. The other equation starts at up 5. And it goes down 1 over 1. I will always encourage you to graph this until you come to the point where they